Hello again, it's Mr. Hine. I hope you can find this video useful to you. This one is a more important one, and that's using summation notation, which I introduced in the last one for a left and right endpoint. All right, and we'll work through an example similar to one of the problems you'll do, and hopefully this clears it up for you. So let's say we have a function f of x equals x squared plus 6x plus 9. Why not? And we're going to look at this on the interval from 0 to 10. And we'll do different amounts of rectangles to help you see how to write summation notation. So let's say we want to do 5 left endpoint rectangles. So if we want to do 5 left endpoint rectangles, remember that a rectangle has an area of just base times height. And if I make a visual of this to help you see this too. So I believe the graph would look something like this, and 0 to 10 is a sketch. Now, to get if we're doing left endpoint, your first one's at 0, and then we're going along the way using the left point of the rectangle up to the curve and over. All right, so that's left endpoint. Now, if we wanted 5 left endpoint rectangles, what you first need is the base or the width of every rectangle. So to get the base or width, you look at your entire subinterval, that distance, so I'll do 10 minus 0 over how many rectangles, which is 5, in which case here I'll get 2. So every rectangle in this problem is going to have a width of 2. Right? Granted, it's not a perfect drawing, it's just a sketch. So then your area is going to be 2 times, now let's go through what those rectangles would be if we were to write this out brute force, and then you'll develop the pattern to see what the summation is. So if I do examples B, C, and D, you can catch on to how I did it so quickly. So if it's left endpoint, the first one is going to be the function f at 0. So it'll be f of 0. So that's the height of that first rectangle. Plus the next rectangle, well, if I'm 2 over, so let's see if I can make this picture better now. So 0, and then I go 2 over. Well, then my next rectangle will be at f of 2. And notice that the height's still the same. It's still a width of 2. So I go over at 2, I go up to the curve and over a width of 2, which would get me to 4. So now I have 2 rectangles. And then my next one is I'd go at 4 up to the curve and over. So then that would be your width, your base is still 2 for all of them. And the next one would be f of 4. And then the next one at 4 would go over to 6. And after that, it would go over to 8. And 8 would be the last one that gets me to 10. So f of 8 plus 2, f of 8 is the last one. Because at 8, if you go a width of 2 over, you cover that entire span of 0 to 10. And there is 5 rectangles there, 1, 2, 3, 4, 5. Mm-hmm. Now, using summations, though, notice how these are very similar in what we're adding, 5 things we're adding. So if I want to use summation area, so I could do a summation of all of them is 2, so I can almost factor out a 2, and just do f of 0 plus f of 2 plus f of 4 plus f of 6 plus f of 8, so that's using some algebra. And left endpoint will go from 0 to 4. All right, so if it's left endpoint, always start at 0. If it's left, go from 0 to n minus 1. And if it's right, go from 1 to n. And you'll see that, and I'll show you that moving forward. So then, notice that this is a linear pattern. If we look at 0, 2, 4, 6, 8, Well, that's a linear pattern. It starts at 2 and adds by 2 every time. So then we could write area is equal to I equals 0 to 4 of 2, and then we can put f of 0 plus 2 I, and I use I because that's the variable for my summation here. And there it is. That's my summation. That's correct. This right here says what this says up here, right? The 2's pulled out, and then it's the function 0 plus 2i, where notice if I plugged in 0 first, 0 plus 0, I'd be at f of 0. Plugged in 1 next, because the next index here would be 1. That would give me 2. Plug in 2, I'd be at 4. Plug in 3, I'd be at 6. Plug in the 4th, the last index, I'd be at 8. Right? And if you were to, a better way you could write this is, remember, anything multiplying, you could always pull out in front. So I'm going to put 2 summation I equals 0 to 4 of f of 0 plus 2i. And I know you can simplify that, but I like to write that so you know it's a linear equation. You can do that. And that's your answer. One of these two, either this one or the one above it is your answer here. If you want to write it in terms of the actual function, f of x equals x squared plus 6x plus 9, then you would write area is equal to 2 from 0 to 4, your summation, and then you'd plug 0 plus 2i into your function f, which I'll write up here again now that's outside the video. So it would be 0 plus 2i squared plus 6 times 0 plus 2i plus 9. And that's the same thing, but using the function here. This is something you could actually put into your calculator because you're telling the calculator what the function is, while this one is just the step before it of what it is. Right? So there's your answer for A of that summation notation of 5 left endpoint rectangles. All right. For part B, say I wanted, so let me rewrite the function up here. So it's f of x equals x squared plus 6x plus 9 from 0 to 10. And we're going to pick up the pace now. So let's say we wanted, we'll keep it simple on this one too, 10 left endpoint. So then the area is going to be the width of each rectangle, which 10 minus 0 over 10 is just 1. So the width of each cycle is 1. So I'm just going to put that outside in the summation. And then we'll go from 0 to 9 for the 10 rectangles. And then it's the function at 0, which is your left endpoint, because that's where you start at, if you did left endpoint. And then the next width, it would just be the next widths over for the next rectangle, so it'd be plus 1i. And there's your left endpoint. And that's your answer for this one. Keep going. Let's say you wanted 7 left endpoints. But I'm going to switch it up here. But let's do it on 2 to 11. Why not? Make this one kind of strange. Okay. So then here, your area would be the width of every rectangle. So we have 11 minus 2 over 7, which is 9/7. So it'd be 9/7 from 0 up to 6 for the 7 rectangles. And then, so that's your base of every rectangle, and then the height of every rectangle would be f of the starting value, which in this case should be 2 plus, so that's what I meant by the left endpoint, because that first left endpoint is where the first one will be, plus the how far over the next rectangle, which is 9/7, so it'd be plus 9/7 I, and there's that one. And hopefully you're catching on here and you can see how that works. Now, say we wanted right endpoint for these 3 problems I just did. I'll do this in red now. So if I want, or we'll look at these last two. Say you wanted 10 right endpoint. The only difference you do is your notation now goes from 1 to 10. So that is your only change to have right endpoint. This stays the same, f of 0 plus 1i. And the reason for that now is that now if we plugged in 1, Now we're looking at the function and we're skipping the first index because at 0, you're at your very first index. So if I come way back to, say, when I wrote this out up here, or better yet, right here, I'm sorry, this is a better one to look at. When you plug in an index of 0, we'll get f of 0. But when you plug an index of 1 here, you plugged in 1, you're starting right here with an index of 1. Following the same pattern, that is. And then what will end is, since you're going 1 farther, it will add on f of 10 for your last index. And that's how write endpoint works in a nutshell. If you want to see it in more detail, I'm more than happy to. But I'm trying to speed it up so you don't have too much work during this time, but still grasp the material. So it would go 1 to 10 of 0 plus 1i. And that's this one B. Say we did this one here. We wanted 7 write endpoints on 2 to 11. Then it would be your width, which is still 9/7, summation of, we'll use j now, j equals 1 up to 7. And it will go f of 2, because it's still your starting value, plus your next rectangle over, which is that width moved over, width being 9/7, then j. There's the next one. Oh my gosh, I didn't show you any of that. There you go. There's the next one. My bad, poor video skills. So it'd be 9/7 for the width of each rectangle. And then right here, pattern stays the same, where you start at your left endpoint plus how it's changing. So the next rectangle over be that width is where the next one you'd find, plus 9/7. Then, but the only change is it's going from 1 to 7. I hope that helps, but that's how you do left and right endpoint with summations. Amazing thing to understand because it will definitely speed up a lot of problems. All right, good luck. Come ask me questions in office hours or email me if you have any particular questions or want me to go in depth. All right.